Hey, all right, everybody. So it is week 5. This is lecture 10. Hopefully the video comes up. All right, there we are. So I'm just webcasting now from Billings, Montana. I'm attending the NCAT, so the National Center for Appropriate Technology Harvesting Clean Energy Conference, and just wanted to give you something to chew on this week for NRGY 270. As you know, this is Glass Week, and a couple days ago I posted an image of a technology that I would love to see implemented in Missoula. So if you recall, in some of our first lectures, we talked about the differences between artifacts and materials. So obviously, material is something that is comprised of a chemical compound and might have an amorphous shape. So take, for example, just a ball of glass prior to becoming a bottle, which is an artifact. Or you could also think of once that glass has served its lifetime as a vessel for holding fluids, it could then be pulverized back down into smaller pieces of glass, and now it's once again a material. So what I'm proposing here is, rather than this sort of single-use policy or practice or what have you that we have for our containers, is that we keep that artifact as an artifact. We know that there is a lot of embodied energy in glass, as there are in other materials. We studied that a couple weeks ago, and so now that you've got you've gone through the trouble of getting that glass up to temperature, melting it, forming it, shipping it. Now it's here in Missoula. Well, what do you do with it? Do you put more energy in to pulverize it, similar to the problem that we worked a couple weeks ago with shredding plastic to add value to turn it into a waste to energy product? Or do you maintain that artifact in its shape, in its useful shape, and repurpose it? Now, what I want to share with you today is an invention that I've come up with. This may or may not be patentable. Sorry if I'm making a public disclosure. So it's free for the world. I would just love to see the thing get built. If somebody wants to take and run with a trademark on it, that would be fantastic too. So let me just hop into my own email here and show you a better drawing that I made in my notebook. I think the one that I showed you a couple days ago probably was not quite as legible as it could have been. Okay, so there's one. I'm going to just file, make a copy. I'm going to save this, NRGY 270 glass. There's one. And then I'm going to go back into my email, pick this one up, file, make a copy, NRGY glass. Okay, so let me walk you through this a little bit. And again, I apologize. This could be a little bit more legible. So let me just pop into PowerPoint, and I'll show you one kind of quick and dirty way to take a drawing that could use some help and turn it into a slightly more technical document. So let me see if I can't get this slide to show up as a portrait. So slide size, custom slide. I'll turn this into a portrait, and I'll have it be sized for letter paper. Maximize, sure, maximize, sounds great. Okay, so now I'm going to go File, Save As, and I'm going to put this little PowerPoint into my documents, Courses, NRGY 270, 2015. Actually, let's just put it into Glass. And I've got to name this thing. I'm just going to call it water catchment. Catchment. All right, so save, insert. Now let's take this picture. And recent places, I was just in Glass. I'll view these extra large icons. This is the drawing that I want to focus on first. I just downloaded this guy. Okay, so first I'm going to take and just go ahead and rotate this 180. I'll make it as large as I can. This is out of my scientific notebook or my engineering notebook. And this is a drawing that you might be able to submit in a patent format. And I'm looking at it now and I'm realizing that I might need to change the contrast to make some of this a little bit more legible. So let me do that if I can. Format, corrections. It's a little better. Ooh, boy. Okay. Just trying to kind of find a sweet spot here. It might be about as good as it's going to get. So what I'll do next, I think the drawing is clear enough, but what I want to show you is that I've sort of labeled each one of these things. So I've got number one over here. In fact, I'll just go ahead and put in a few little things. So I've got number one is the bottle itself. Let me see if I can do this too. Insert a shape. I'll just go ahead and make a circle. Put this guy like so. Take that, format it. I will do no fill on that, and for a line I'll make it black, and I'll make it a little thicker so it's easier to see. And I'll make it a little bit rounder, good enough. And then I'll take that, copy and paste it, and now I can kind of use that same symbol throughout. So number one, and simultaneously, so I will come up here and do an insert, and I'm just going to put a text box in, and I'll just walk you through sort of the design criteria of what I'm looking at. And what we're looking at, by the way, is a way to repurpose a wine bottle for water catchment. So the very first attribute is that you've got free materials. Well, you know, you've already purchased the materials, of course, but at this point, you know, glass to the consumer who's already consumed the contents of the container, the bottle becomes a liability. And so what we're trying to do here really is turn it into an asset. So, you know, again, this is kind of one person's trash is another person's treasure. So you might, if you decide to take this project on, you will have unlimited access to free bottles, I guarantee you, at least in Missoula, Montana for the time being. Okay, so you've got free materials is the first aspect. So number two, you've got durability. So glass is extraordinarily durable material. It's not very tough from a fracture point of view. Obviously, if it gets impaled by something, but you know, bottles are designed. You know, wine bottles in particular are designed to be shipped thousands of miles via ship or truck. You know, lifted. Various bottles have drop tests standards for them. So obviously, if one bottle within a case breaks, it doesn't ruin the batch. So these are well engineered and durable vessels. The next thing we're looking for is safety, of course. And you might argue, well, you know, glass is a safety issue. In fact, we learned during our landfill lectures that, in fact, if a glass bottle comes in through the conventional recycling stream at the University of Montana, that entire bag goes into the landfill because the workers and volunteers that are sorting through recyclables at the university, you know, they're wearing rubber gloves. They're not wearing glass-proof you know, gloves that would protect their hands from cuts from glasses. So to reduce their exposure to cuts and abrasions, they're really forced at this point, since there are no mechanized systems currently at the university to handle that, they're forced to throw any conventional recycling streams that are coming in that have glass contamination into the landfill. So safety is a big concern here. Another one, of course, is aesthetics. That's something that engineers don't think quite enough about, and that's why we have design teams to take care of things like that. So, and I'm not sure if you've ever been in the Rattlesnake, you might have seen the glass wall that Beth Schenk constructed there. I think it's at the corner of Rattlesnake Drive and Holly Drive, just as you're coming out of the lower Rattlesnake and up into the upper Rattlesnake. So it's gorgeous. She's used pulverized concrete and glass, sort of flowing this nice wavy pattern, a lot of neat colors, and again, just turning a liability into a very aesthetically pleasing asset. Manufacturability is another one. How hard is it to make this thing? You don't want to have so much time and energy and effort invested in manufacturability that you sort of price yourself out of a market. So that's another design thing to consider. And if you remember back, if you're following along and reading in the Cradle to Cradle book, I think one point that's made there in chapter 1 is that really what we're doing here is design, and manufacturability is part of the overall design. We're sort of redesigning the world of manufactured artifacts, if you will. Cost savings is another one, obviously. So again, if we're going to flip this big waste pancake over, what I would, in fact, I just want to a little segue here. I got some disappointing news from Martin No Runner this morning of IE Recycling, saying that the target group that we sent our proposed zero waste letter out to was not very well received, and we're trying to figure out exactly why, whether people just didn't see it in the mail, thought maybe it was junk mail, if perhaps it was too expensive. I think Martin's initial proposal was to have a $600 per year curbside pickup fee. I believe the Republic Services right now with their curbside is something on the order of $250 to $300 per year for just landfill service, and then an additional maybe $50 to $100 for their kind of upstart recycling service that they're providing. So I'm wondering if the cost was an issue, or the third deterrent could be just the hassle. And I think one thing that you've probably noticed from the lectures so far, and perhaps from your own practices, is that it is a hassle to separate waste into multiple streams. But that's again part of flipping that pancake, if you will. Okay, and then the next one, I guess, is for market. Is it trendy or not? And well, we'll see. I don't know. Okay, so those are kind of the things that would make this, sort of make or break this technology. Now let me just walk you through the overall design. Okay, and I've got 9 components overall. I'm going to see if I can fit them all here. So number 1 is just the bottle itself. That's number 1. Number 2 is the H2O tube. And let's take a look for number 2 on the... There's number 2 down here. So you can see at the bottom, what I have is a water tube that is coming from, and this could come from rain catchment. What we're really trying to do here is catch water from the roof of a house and capture it. This could help mitigate stormwater runoff. It can then provide watering for livestock. It could provide water for like a gray water system for toilet flushing. I don't see a problem either feeding this into a shower system. Depending on where you live, rainwater might not be immediately potable for human consumption. Depending on it's hitting the roof, and you might have leaves. You might have bird droppings, of course, that you would not want to drink. But depending on the levels of potential contaminants, if you will, in the rainwater, there's obviously a lot that you can do with it rather than just letting it sort of act as runoff. Okay, so number 2 is the water intake. So you can see the water intake. Note that the water intake only stops right about here, sort of. It does not go all the way to the top of the bottle. And so what makes that water level rise? Well, you've got another larger reservoir somewhere on your drainage system that provides enough pressure to force the water into the bottle. Okay, number 3 is a cork. And so with your bottle of wine typically comes a cork. And here's what I'm going to do, copy 4, 5, 6, 7, 8, 9. So I'll just kind of grab these guys off as I go. All right, so that's 3, pointing to the cork. There it is, and obviously you would need to put a hole through that cork. Most likely some kind of fitting here, depending on the flexibility of the tubing coming in. Again, simplicity is certainly an issue. So if you can get away with a single piece of tubing that comes in through the cork, all the better. However, depending on this angle, you might consider some type of fitting. But nevertheless, the tubing passes through the cork and into the vessel itself. All right. Number 4 is the H2O opening, and that's just right there at the top of that cork, obviously. So that's where the water itself enters the main vessel. That's number 4. Number 5 is the air tube. Why do you need an air tube? Well, if you do not have a way for air to escape, then excessive water pressure would build up. So we need a way for air to escape. That's part number 5. And notice that the air tube extends nearly to the top of the bottle. The reason for that is as the height of the water, the level of the water increases, it will increase to the point where the top of the tube is present. Any air in this head portion is then forced out and down through the air tube. Okay, part number 6 is the bottle flange. So typically what you'll see on a wine bottle is some type of flange. Not always, but that's typical, and that's where your wine opening device can sometimes grab the bottle for opening. Not critical, but I just went ahead and drew that in there as well. Part number 7 is an O-ring. Let me grab that. Part number 7, so let's just catch up to where we are. So there's the cork. Part number 4 is water. Let's be technical, H2O. Copy. H2O opening. Part number 5 is air tube. Part number 6 is, well, I'm calling it the flange. I think that's an appropriate name for it. Or neck, or sometimes it's called a shoulder. 7, again, this is going to be a seal, perhaps an O-ring. An O-ring seal there, just so that, because obviously when this system, if it were to leak, you would well, if a leak were to occur down here between the water tube and the cork, whatever container, now as I'm speaking, I'm realizing that I did not properly label this other component, so we'll do that at the end. This sort of fitting. We'll just call this entire thing the fitting, and I guess I'll label that as number 10 here when we're done. But if water were to leak into the fitting, this O-ring would prevent it from basically spilling out and losing the water inside. Okay, and then number 8, as I have labeled it, is the water level. Label that guy, water level. Number 9, I'm going to make a copy paste on that guy. Number 9 up top is the air intake. And then finally, number 10, I just realized I'd left this off. Very kind of funny. That actually one of the more critical components there is, and I'll go ahead and draw a little squiggle to it as well. Hello. Oops. Grab both those guys together. And I'm just going to call this thing, and I'll go ahead and insert a shape. I'll get one of these little squigglies going from here. Try to redo that. Insert. You probably can't see that the default shape is, I'll just make an arrow. What the heck. From here over to here. Line color, let's make that black, and let's make it thicker. So, and we'll drag down our legend so we can get everything. Let's just put it right in the middle there. 9 is the air intake, and then 10 is the fitting. Okay, and then the fitting really holds the whole system together. Okay, so now that we understand the basics, let me show you how this device, this water catchment, would be put into a larger system. And I've got a second image that I've drawn. And I apologize if you were sort of struggling to read this image previously. It's more or less what we're reviewing right now. It's kind of a side view of the whole system. But what I'm showing now is a top view, well, a top view and a side view. So at the very top of the drawing, which is a photograph of a drawing I made, is how you might stack these bottles in an array, sort of a hexagonal close packing. I've just sort of shown 2 rows. You might have a front row of some color and a back row of another color, or whatever aesthetics might suit your fancy. And then, you know, relatively simple compression structure. So each one of these sticks is going to be held in some kind of compression and perhaps bending. There are pins here at the corners that hold them together, and then keeping the whole thing together, you might have some kind of tension members. What I'm also showing is that you're going to need some type of washer or gasket or bearing, and again, this is something that can be the details to be worked out based on materials that are on hand. I've thought perhaps of using, you might use some fabric. In fact, we send a lot of fabrics to the landfill. We send a lot of fabrics back to Home Resource, or to Goodwill, and I could see using repurposed fabric to provide as a little bumper or cushion between the bottles. Another repurposing of a material that otherwise would be going to waste. And at the bottom, you sort of see a side view of what this might look like. And just to go into a little bit more detail, these lines, if you see these sort of skinny lines, what I've tried to do is have them sort of alternating by supporting the necks. So the short lines here on the upper drawing are depicted here in the bottom half. So these are strategically placed so that the bottles more or less slip into place, keep everything aligned, and then the top bars, which are shown here obviously, and then surrounding this inverted wine rack, would then keep the tops from falling over. So you have a bearing system on the bottom, a bearing system on the top, and away you go. These fittings, of course, would be housed in a manifold on the bottom. What I haven't shown off to the right over here, and I'll just go ahead and draw it in, go outside the boundaries of the screen, but that's okay. Let's do no fill, and the solid line is going to be black, and we'll insert, let's do this, copy paste, flip this up, get that a little shorter, scooch that over, color, let's just make that blue for water, solid fill, and there it is. Okay, so this would be the water level. If we can take that, copy paste that again, we could take this whole so here's the water tube coming off the bottom, feeding the manifolds, and then this line, insert shapes line. This line would represent the water level in the system, and in order to achieve that, copy paste, you would need some type of overflow valve in your reservoir. But this reservoir would just be mounted on the side of the house, and just this is going to be not too fancy of a depiction, but off comes the water, copy paste, and then down into the system. Okay, so this is the supply from the roof into the reservoir. Off to the right over here is the overflow valve if the water is coming too quickly, or if in fact the system is full. This is the system of tubing, which I depicted here. So the 2 and the 5 are more or less in this portion. Obviously the air would be there as well. This short blue line is the top water level, and there you go. There's water catchment. Now you might say, well, let's just get a big rain barrel or what have you, but going back to some of the design criteria, the materials are free, glass is durable. If it's built again and you need some way, and I mentioned spare fabric between the bottles to keep it safe and from breaking. It's got to be aesthetically pleasing. I mentioned the Beth Shanks wall, and I think we could do something comparable. Manufacturability, there's really no, it's just more or less hand assembly. You could imagine, making a jig if you were to start mass producing this. Cost savings, well, if you look at your water bill, you're more or less paying for water to be pumped uphill, and that's an energetic cost, typically with a carbon footprint, and then that water is, of course, coming back down to you. In this case, all of the water that you're getting is coming from the natural hydrological cycle, so it's powered directly by the sun. Water's through the evaporative process. And then trendy, well, we'll see. I don't know. Again, I'm giving this lecture through the NRGY 270 course at the University of Montana. We're broadcasting it live, of course, because we have students around the country interested in this, and we'll see if it catches on. So, this is going to become a YouTube video, and looking forward to hearing what you all have to say. So, back to my students, I'll hop back into the shell and see what kind of questions we have for this week, and I will be back in the classroom on Tuesday. So, thanks, everybody. See you next week. Right at a half hour.